am Jamila Awada. I've been in Luxembourg since 2009, and I've been a researcher here for 15 years now. So my expertise is in computer vision and machine learning, artificial intelligence. So typically computer vision is all about enabling machines to automatically understand visual data and extract information from it. Basically the way we do it naturally as humans, but enabling machines to do that. And while in the past it used classical approaches, nowadays it's very much entangled with AI and machine learning, meaning we need a lot of data to train our models and train the machine to automatically understand. A typical and easy example to understand, example in computer vision is face recognition, so automatically understanding and recognizing faces. And one of the challenges that we worked on is to be able to do it robustly despite any motion, any occlusion or bad lighting. So that's a challenge in itself that we worked on. And what is exciting about it is basically learning the fundamental geometry and behavior of a human face, which is quite tricky, especially to capture the subtleties. And this insight actually helped us to dive into another domain, which is deepfake detection. Deepfake, synthetically generated faces, how to detect those, especially with the advancements in AI and machine learning, where the synthetic or deep fakes are becoming so realistic. A huge challenge is to be able to distinguish between the fake and the real. And this is where our background in computer vision and geometric modeling helps us to be able to distinguish those. Well, 15 years and 15 years, I like to reflect on those and see how our research team has grown, the CVI2 research team. And I like to think of the methodology, how we built that research group, starting from one industrial partner and then building a portfolio. So the approach has always been to look into the industrial challenges that are brought to us by our partners. And then obviously as researchers, we need to find an underlying direction, fundamental direction. And it's been consistently geometry and topology of data, how to embed that information into our models, into our AI models. More specifically, I can talk about one specific project, human body modeling, where the geometric representation of a human body was all the task there, and being able to do it efficiently, but also keeping in mind all different variations from the sensors, so ending up with a model that could be used later on for applications for healthcare, for fashion, entertainment, etc. And why I think about this specific project, because it is very Luxembourg based, where all Luxembourgers or a lot of residents in Luxembourg contributed to this project. I mentioned that data is very important for AI. Well, everyone chipped in and everyone came to our booth where we deployed scanners, body scanners, and we collected data from Luxembourgers. So we have now a database of over 3,000 body scans. And the exciting thing is that it contributed to the development of our AI models, but not only ours. It's also a data set that we share internationally with the international community, with over 200 institutions. I have to also add that we do it in keeping all the GDPR rules and consent and confidentiality in check. So that's important to add. The other highlight is linked to deepfake detection and how we are managing with my team and my excellent students to be in the forefront of research. So deepfake detection is extremely fast-paced research where everyone is building models to create the fakes, and we're there to build models to detect those fakes. And it's extremely competitive. And what is exciting to me is that we're managing as a team, and my students are doing a brilliant job by building some of the most competitive models, exploring the theme that I mentioned, the geometry, but also the temporal aspects in detecting the fakes from the real ones. The future in AI looks really bright. I mean, today there is a huge explosion. Innovation is coming very quickly with the latest advancements in LLMs, large language models, and VLMs, vision language models. There is a lot of possibility for us. And what is exciting is to be able to bring this geometric modeling and enrich it with more contextual information with language cues. That's exciting in itself, but also maybe inferring more geometric information into these models, language models, and extracting geometric information. So that can open a lot of more possibilities, and we're very happy to see that our industrial partners are looking at it the same way, and they're equally excited.